tolerance zones are same, that we can, this purpose can be solved by only one gauge, means the one gauge can serve the purpose of both the workshop and inspection. But in this case, since the tolerance zones are different, so we have to make one workshop gauge different and in inspection gauge different. Now second system, which is the revised. Now under this system, the disadvantages of inspection gauges, they are reduced by reducing the tolerance zone of the inspection gauge. Means in what we have done in this system is that the tolerance zone of the workshop gauges remains the same, but we have reduced the tolerance zone of the inspection gauge to make them same. Now the third system, in this new system, this is again followed by the principles of Taylor's principle. The tolerance should be as wide as is consistent with satisfactory functioning for economical production and for inspection. Means the tolerance should be as wide as it can. Then no work should be accepted which lies outside the specified limits. Means the workpiece which is outside the specified limit, we will never accept it. Now the tolerance zone of the, for the go gauge, it should be placed inside the work limit, and tolerance for the no go gauge, it should be outside the work limit. Mean to say that go gauges, they should be within the lower limit, and no go gauge, it should be for the higher limit. Now we should also there should be a provision for the considering of the wear allowance in case of both go and no go gauges. Wear should not be permitted beyond the maximum metal limit. Now next comes the mechanical gauges. The mechanical gauges, they are the best suitable for measuring very high fluid pressures. In case of steam boilers, where manometers cannot be used, a mechanical gauge can be easily or conveniently used for that purpose. Now what is the working principle of all mechanical gauges? They are same. Now there are different types of mechanical gauges. Number one is the Borden's tube pressure gauge, second one is the diaphragm pressure gauge, and third one is the dead weight pressure gauge. This is the diagram of a Borden tube test gauge. Now in its simplest form, it consists of a elliptical tube bent into an arc of a circle, which is bent into an arc of a circle. Now this bent up tube is connected to the fluid, or the pressurized fluid, it flows into the tube as a result of increased pressure. Obviously when the pressure will increase, the pressure will flow into the tube. Now with the help of simple pinion and sector arrangement as shown in the figure, the elastic deformation of Borden's tube rotates the pointer. Due to the elastic deformation of the Borden's tube, the pointer will rotate and the pointer moves over a calibrated scale, and this directly shows the pressure. Now this diaphragm pressure gauge, it is used to find out the pressure of a fluid above or below atmospheric pressure. This is basically used for measuring the relatively low pressures. Now dead weight pressure gauge, it is generally used for the calibration of the other pressure gauges in a laboratory. Means for calibrating of the Borden pressure gauge and diaphragm pressure gauge, we use these dead weight pressure gauges for calibration purposes. Next comes the principle of strain gauges. The strain gauges, they are measure the deflection or deformation of a material to which they are attached. Means when we apply a force on a material, naturally it will get deformed. So that deformation, it may be a contraction or expansion, that is measured with the help of these strain gauges. Although there are several different types of strain gauges made of different materials, but the basic principle of these gauges is, number one principle is deformation, second one is change in electrical resistance, and third one is the change in temperature. Now first comes the deformation. Naturally, when a force is applied or to any substance, then what happens, it introduces the stress, and that changes the shape. Means the, suppose we consider a rectangular object, so when we apply a pull force, it will become longer and narrower, but when we apply a pushing force, it will become shorter and wider. These mechanical strain gauges, they display this change in shape by displaying the distance that a point on the substance moves. How much the pointer will move, that will be the change in the shape. Now, this actual distance, it is usually amplified mechanically and displayed by the dials. The dials which are on the mechanical gauges, they give us the value of that distance. What is strain? You already know, strain it is defined as the change in length divided by the original length. So, it is a dimensionless quantity, it has no dimension. Next comes the resistance gauge. Now, since the electrical resistance, it is the intrinsic characteristic of material, though this change in electrical resistance, it is caused by the due to geometry. We can say that due to a change in geometry of that object, we can say that the resistance also gets changed. Suppose we can say for a longer piece of material, naturally it will have more electrical resistance as compared to shorter piece. So, we can say that the change in shape of an object is induced by an external force, which causes a change in the electrical resistance. They are linked to each other. For what happens, force causes a change in the shape, and this shape, this further causes the changes in the electrical resistance. Next comes the temperature compensation. Not, we can't say that force causes the changes in the length of the object, means the contraction or expansion, it is not only due to the stress, it is also due to the temperature, because naturally if the temperature is high, the object will be expanded, it will cause expansion in the object, and if it is temperature is very low, it will cause the contraction of that object. So, this factor should also be taken into consideration. So, this is the strain gauge. Next comes the principle of a vacuum gauge. Now, pneumatic gauges, they are operated by taking in a sample volume of gas from a vacuum chamber and then compressing it by tilting and infilling with the mercury. It is being compressed and it is filled in mercury. Now, the pressure in this smaller volume is then measured by a mercury manometer, and by knowing the compression ratio, the pressure, it can be determined with the help of the Boyle's law. We can measure the initial pressure and final pressure, and initial volume and final volume. Now, this method is fairly very accurate for non-condensable gases such as oxygen and nitrogen. The result is that we get a error-free reading which shows us pressure, the value of pressure. The advantage of this vacuum gauges is that it is simple to use and that its calibration is nearly the same for all non-condensable gases. Means we can use any condensable gas, the calibration will be same. Now, this is the McLeod gauge. It is a example of a pressure vacuum gauge. It was invented in 1874 by Herbert McLeod. They were attached with the equipment for which we are going to check the pressure. Today, these gauges are being replaced by the vacuum gauges. This is the diagram of a McLeod gauge. Next comes the pneumatic gauges or air gauges. They are used primarily to determine the inside characteristics of a hole. I mean, how the hole is from inside, we check with the help of this pneumatic or air gauge. These are of two types, flow type or pressure type. Flow type, in the flow type, what happens is that we measure the air velocity keeping the pressure constant. In case of pressure type, we measure the pressure by keeping the volume of air constant. Next comes the optical gauges. Optical gauges, they are based on the principle of projection of image, means we project the image and from that image we can identify the measure the that image. A simple optical comparator for measuring of linear dimensions is shown in the figure. So, this is showing the optical gauge. The arrangement consists of mechanical system which covers the plane reflector to tilt about an axis, so that the image of an index is projected on the scale on the screen on the scale on the inner surface of a ground glass screen. Now, the actual difference x between the two dimensions is amplified by a lever to give an angular displacement theta of a pivoted mirror. Now, the reflected ray is deflected through an angle 2 theta. It gets deflected through angle 2 theta from the original line and gives the reading x on the scale. Now, the main advantage of an optical gauge is that it is capable of giving higher degree of magnification due to reduction of moving members. But because moving members are very less, so we can get a higher degree of magnification and better wear resistant qualities. So, next comes the electrical gauges. Electrical comparators or gauges, they are used as a means of detecting and amplifying small movements of a work contacting elements. It may use any of the following transducers for magnification. They are strain gauges, variable inductance transducers and variable capacitance transducers. So, what transducers do? They convert the displacement into a corresponding change in current, and a meter recorder connected in the circuit to indicate the electrical change calibrated to show in terms of displacement. Generally, we use an amplifier, or amplifier is used to provide the required sensitivity and to match the characteristics of different parts of the circuit. Now, these electrical gauges, they are of different types. One of them is called as an electro limit gauge. It is used to check the or measure the outside diameter of a roll. Now, the object to be checked, it is placed on the anvil under overhanging gauge spindle. This is the diagram of the electrical gauge. The movement of the spindle for its deviation from a standard dimension unbalances an electric circuit. Now, there are a number of advantages of electrical comparators or gauges. First one is that they have little or no moving parts, main advantage. Therefore, what will happen if the moving parts are less? Naturally, they maintain their accuracy over long periods. Now, if in addition the sensitivity of these comparators can be adjusted at will to suit the type of measurement being done, means from simple object to complex object, we can easily measure with the help of the electrical gauges by adjusting the sensitivity. Now, electrical comparators, they can give magnification from 600 to 10,000 according to the meter. Now, this is the diagram showing the electrical comparator. Now, this is the summary. So, let me tell you what we have discussed so far. We have discussed about introduction to gauges. Next comes the classification of plane gauges, that I have told you that standard gauges, limit gauges, plug gauges, snap gauges, ring gauges, taper gauges. So, these were the classifications. These come under classification. Next comes the Taylor limit gauges. I have told you that limit gauges, they are of two types, go and no go gauges. Next comes the Taylor's principle, which tells us that the go gauge, it should follow the maximum consideration, and no go gauge, it should follow the minimum consideration. Next, we studied about the wear allowance. Then we studied about gauge maker's tolerance, and then finally we studied about the principles of various gauges: mechanical, strain, vacuum, pneumatic, optical and electrical. Thanks.